Okay, this is the differentiation of inverse trigonometric function. The derivative of this is our question. The derivative of inverse sine. This is our question. And reminder, this is rule of inverse trigonometric function that I use for this question. Inverse sine. This is 1 divided by square root of 1 minus x squared. The derivative of inverse sine, while I'm doing this, I will also going to use a chain rule on this one, but notice how this time the inside piece is the inverse sine. So let's take care of that outside piece. Now I will like this. I will bring down the power for I will bring down the power here and reduce it by 1, so become 3. While now the inside will stay exactly the same, so it just inverse sine of x. And now, I will write it down again. Y equal 4 inverse sine x 3 power of 3. I will multiply this by the derivative of inverse sine. This 1 over square root 1 minus x squared. Here is where we get to use that fraction. So let's see the derivative of inverse sine. I have let's see 1 divided by the square root of 1 minus x squared, like this. Might as well combine everything into a single fraction, so we put the 4. So we put the 4 and the sine inverse of x power of 3 on the top, and I will just leave all the other square root 1 minus x squared in the basement. So this is our final for this question. In this video, we are talking about inverse hyperbolic function, and more specifically how to use an inverse hyperbolic function to evaluate an integral. So in this particular problem, we have been asked to find the integral of dx divided by square root 4x squared minus 16. Reminder, this is formula of inverse hyperbolic function that I use for this question. Integral du divided square root u squared plus s squared equal inverse cos u divided a plus c. Stop. Based on the formula here, let a squared equal 16. Then we get a equal square root 16. Then a equal 4. Then based on this formula here too, let u squared equal 4x squared. U squared equal 4x squared. Then u equal square root 4x squared. Then u will become 2x. Okay, so now we are going to make u substitution for 2x. The reason we are going to do that is because we set u equal to 2x. We are going to be able to manipulate our function into this form here. So we are to go ahead and say u is equal to x. Then we are going to take the derivative of u and we are going to say du divided dx equal to, then make du equal to dx. We want to solve this for dx, so we will divide both side by 2 and we will say dx is equal to du divided by 2. Okay, so now what we can do is we have here 4x squared let's 4x squared equal u squared and 16 equal 4 squared. We gonna plug in them into this formula here, and dx equal du over 2. We gonna plug in for dx here, so it will become here. We know that dx is equal to du over 2 and the integral become like this. 1 divided square root u squared minus 4 squared dot du divided 2. So we can go ahead and say then that the integral value is inverse hyperbolic cos of u divided a plus c. I can write like this: 1 divided 2 inverse hyperbolic cos u divided 4, because in the last previous step we let a equal 4. We know that a equal 4 and u equal 2x. Then plus c. So we write again 1 divided 2 inverse hyperbolic cos. We just plug in u and this is a. We just plug in u and a here. So u is 2x over a equals 4 plus c. Then we can simplify 2 over x we can simplify this 1 and 2. So the last final answer is 1 over 2 inverse hyperbolic cos x divided 2 plus c. So this is our final answer.